All right, hi, good day all. So today we will be doing January 2023 paper 3. Now paper 3 is more practical based, meaning it's more real life things that they're giving you to answer these questions, right? So it's not just exact find this and this like paper 2. This one they would give you uh, um a situation that has occurred and how you would solve it using maths, right? So this question has the diagram below shows the view of Pinky's house, which includes 4 windows and a door. You see the 4 windows and a door. Calculate the total surface area of the front view of Pinky's house, inclusive of the windows and doors. So we're not excluding the windows and doors. So this, if we look at this, we can see there are 2 regular shapes. We're seeing there's this rectangle and then there's this triangle. So we'll call this A1 for area 1 or shape 1, and we'll call this B1. Now, area of a rectangle, so we'll say area, not B1, we'll call this A2, right? So area of A1, which is a triangle, is base by height over 2. And even if you don't know this formula, guys, this formula is given in the formula sheet. They have it as a half base by height. Right now, if we look at this image, our base is actually, right. So as I was saying, if we look at this, we have the height of our triangle is 3.4, and the base, which is this length here, this length, if you could see the x of this, from here to here, or the black line that I just now drew, is 13 meters. So our base is 13, our height is 3.4. So we're going to put that in where it is. This would turn into 3.4 multiplied by, sorry, not 3.4. We'll put in your base first. Your base is 13 multiplied by a height, which is 3.4, all divided by 2. You can do this on your calculator, right? When you do this, you are going to get 22.1, and this is in meters, and remember it's area, so it will be squared. So that is the area of A1, and then we'll find the area of, let me put this around so you guys could see, of A2, which is a rectangle, and we know rectangle is length by breadth or length by width, whichever one you want to use, right? Your length is always the longer side, it's 13 multiplied by width or breadth is 7.5. Use a calculator. When you multiply this, you're going to get 97.5 meters squared. And then they ask you for the total surface area. So your total will be A1 plus A2, which is 22.1 plus 97.5, which is 119.6 meters squared. And that would be your area for this shape here. The window and doors are made up of shattered-proof glass, right? The door is 2.4 meters wide and 3.8 meters high, right? And each window, how much windows there are? There are 4 windows, right? Each window is 1.8 meters wide and 1.4 meters high. So we can find out the area of your door. The area of the door is a rectangle. We know the door is a rectangle, so it's length by breadth or width, whichever one you want to put, right? So your length is the longer bit, which is 2.8 meters, and your width is 1.2. So you're going to say 2.8 multiplied by 1.2. When you use a calculator, you're going to get 3.36 meters squared. Remember, area is squared, always squared. The power is always squared, right? So that's why I have meters squared. There's one door, so this is how much, that is the area for the door. Then we have area of one window. Now your window, if we look at the sides, one side is longer than the next, so it's a rectangle as well. So area of one window is length by breadth, which is 1.8 multiplied by 1.4. When you multiply this, you're going to get 2.52 meters squared. But how many windows are there in this question? There are 4 windows. They told you there are 4 windows. So if the area of one window is 2.52, then the area of 4 windows would be 2.52 multiplied by 4, which is equal to, when you multiply this by 4, you'll get 10.08 meters squared. So my total area for one door and the 4 windows would be what I just now underlined when you add them up. 3.36 plus 10.08. Do this on your calculator. When you add it up, you're going to get 13.44 meters squared. And that is your answer for this. Now they said Pinky covered, this is part 3, Pinky covered the front of her house, excluding the door and the windows, with decorative wall tiles. So basically, if we look at the shape, let's look at the shape here. They're covering everything in front, not the windows and doors, with tiles. So to find out the area that is needed for the tiles would be your total surface area minus the total for your windows and doors. So the area covered with tiles would be your total surface area, which is the answer we got in the first one, the first part, right, or part 1, minus the total area of your windows, your 4 windows and 1 door, right? So we know the total surface area that we found above was 119.6 minus 13.44, which would be equal to 106.16 meters squared, and that would be your answer for this. So the last question, part B, says Pinky paints one of the walls of the house, which has an area of 53. So we know that it is 53 meters squared. 1 liter of paint covers 4.5 meters squared. A paint is sold at 2.5 liters in a tin, and it costs 2.475. So you see what I'm doing here? I'm underlining what they told you. Then they ask you for the least number of tins. So we want to find out the number of tins, right? So first off, we need to know how many liters. We need to know how many liters in one of these tins. So we know 1 liter is, we need to know how many liters in one tin will cover, what is going on? We need to know how many meters squared with 2.5 liters or 1 tin cover. So we know 1 liter would cover 4.5 meters squared. And therefore 2.5 liters would be 4.5 multiplied by 2.5, which is equal to 11.25 meters squared. So we know that this 2.5, which is also known as 1 tin, would cover 11.25 meters. One second. I was saying, we know this is 1 tin is 11.25. So we know we want to find out how many tins first, right? Before we could find out the cost of for how much she would have to pay to cover the whole wall. So if 1 tin covers 11, we're not going this way. We're saying if 11.25 meters squared is equal to 1 tin, then 1 meter squared would be 1 over 11.25. And how much we have to find out to cover? 53 meters squared. Therefore, 53 meters squared would be 1 over 11.25 multiplied by 53 over 1. When you do this, you're going to get 4 and 32 over 45. Now, we cannot buy 32 over 45 of a tin, right? So because it is tins, we have to approximate this to 5 tins. So first off, Pinky buys the least number of tins needed to paint the wall, so she buys 5 tins. They want to know the cost to paint the cost of paint required to paint the wall. We know that 1 tin is equals to $24.75. She has to buy 5 tins, which would be 24.75 multiplied by 5. So your answer will be 128, not 128, 123.75. And that would be your answer for this question. Now, so we're going on to number 2. Number 2 says Leela cycles along a path for 5 minutes. So we know that the total time that is taken for this is 5 minutes. But if we look at the graph, just like if you view the graph, it's in seconds. So we're going to immediately turn your 5 to seconds. So that's 5 multiplied by 60 is 300 seconds. So we know that Leela cycles for 300 seconds, right? Then they're going to say she starts from rest, which means she starts from 0 and accelerates at a constant rate until she reaches 5 meters per second. 5 meters per second is here. Let me use my mouse to see it. Is here. And they say that is after she reached that 5 meters per second after 100 seconds. So at 100 seconds, she is going to reach at 5 meters per second, which is right here. Now, they told you it's a constant rate, so that means it's going from 0 straight up to that line or that point. So this would be your first, let me just fix this a little bit. This would be how the graph would, well, the first part that they said, right? This is for 5 meters after 100 seconds. She continues cycling at 5 meters per second. So she's going 5 meters per second, the speed, right? It does not change. So it would be straight across for 2 minutes and 40 seconds. Now we know that because you're in this graph, your time is in seconds. We need to convert 2 minutes and 40 seconds to seconds. Now 2 minutes is going to be 2 multiplied by 60, which is 120. So 2 minutes and 40 seconds would be 120 plus 40, which is equal to 160. So for 160 seconds, she's going for 5 minutes. We know that it starts from 100. We're going to for 160. So 100 plus 160 would be, hold on, let me just delete this. Right, so she is cycling for 160 seconds at 5 meters per second. So we already reach 100, right? So 100 plus 160 would be 260. So she is going to start, she's going to have constant speed until they reach at 260. Yes, 260 is here. Right, so this point here would be where 260 is, right? This is where she has her constant speed. Then they said she decelerates at a constant rate until she stops. So if she stops, that means that her speed is 0. So we are going from where she's going at a constant to 300 because the total journey took 300. So it is going to stop at this point right here. So this point right here would be 300 is after 5 minutes, which is 300 seconds, she immediately stops. So this here would be your time graph to show her journey. Right, so now we are going to go into the second part of the second part of number 2. Determine Leah's acceleration. Now we know that acceleration, when they usually ask for acceleration, it also means to find the gradient. So acceleration is equal to your gradient, right? So we know your gradient, or m, is equals to y2 minus y1 all over x2 minus x1. That means we have to find two coordinates, right? Right. Two coordinates on this line that is accelerating, right? Because this one was accelerating from 0 to 100 was the acceleration, right? So we are going to get 2 points on that first line. So I'm going to use this one, which is 0, 0, and then this top one, which was 100, and then 5. Right? You could use others. I'm just going to use the 2 points that are furthest apart from each other. So the 2 points that I'm using is 0, 0, and 105. Right? So we are going to choose one to be group 1 and group 2. So if this is group 1, this is x1, y1, and this is x2, y2. We're just putting it in the formula, which would be x2 is 5, 5 minus 0 all over 100 minus 0, which is 5 over 100. 5 over 100 is actually 0.05. And because acceleration is in meters per second squared, right? If you want to find the units, let me just hold on. Meters per second squared, right? If we look at this, this is how you would find it, right? Your what you call this thing? Your y-axis is in meters per second, so we're going to put meters. So to find your gradient was your y's, which was meters. Hold on, what am I doing? To find your gradient, m, this was meters per second, or meters over seconds, all over. So this was your y divided by s, right? If we're going to, this is meters over seconds, multiply by seconds over 1, not multiply, divide, right? That's basically what it means. Right? So it would be meters over seconds multiplied by 1 over s. That is meters over s by s is s squared. So that's how we get meters over seconds squared. And that is how you get your unit. If you do not know your unit, you can always just put the values that we have, the units that we have, and put it in the formula that was used to get your units that you need, or the final units. Part 3 says Leah's average speed for the entire journey. Now, speed, this is a formula you have to know. Speed is equal to distance over time. We know your distance is your area, not your area, but your total area under the graph. Right? Your time would be 300 seconds. Right? So now, what we have to find is this total area under the graph. Now, if we look at this graph, there are two ways that you can look at this graph. We could look at all the regular shapes that you can get. I am seeing 3, or you could use 2. I'm using 3 so that we can see it. There's a triangle right here. Let me put this in right? So the 3 different shapes would be, we have a rectangle, not rectangle, a triangle. We have a next triangle at the end here. Right, I'll put it in red so that we can see. So we have this first triangle. This is A. So we can find this, we can call this A1. We can call this A2, which is your rectangle, and we can call this A3. Or if you wanted, you could say, well, A2 and A3 is actually a trapezium, right? And if you know the formula for area for trapezium, which is given in the formula sheet, right, you can always just use that. I'm just using the 3 because it's quite simple to remember. So first off, what you have to recall is area of a triangle is base by height over 2, right? So we have to find for A1, our base is from 0 to 100, which is 100, and our height is from 0 to 5, which is 5. So for A1, our base is, I'm just writing this here, but I'm going to write it over, right? Our base is 100 and our height is 5. This is for A1, right? For A2, we can see that's a rectangle. The height or length by width, your width is 5, right? Hold on. Your width is 5, but your length is from 0 to 260, which is 160. So my area of 2 would be 160 by 5, or your length is 160, your width is 5. And then A3, we want it's a triangle, so my base is from 260 to 300. 260 to 300 is 40. My base is 40. And my height is equal to 5. So now that we know all of this, now we can apply it in our question, or not in our question, but to find the total area under the graph. So we're going to find area of A1, which was our first triangle, is base by height over 2, where our base was 100. Multiplied by 5, which was our height, all divided by 2. This is equals to 250. So the area of A1 is 250. Then the area of A2 was a rectangle. Here, length was 160. Length by width or breadth. Length was 160 multiplied by a width, which was 5, is equal to 800. Right? This is meters squared. Meters squared. And then area of A3 is your triangle, which is base by height over 2, where my base was 40 multiplied by 5, which was my height, all divided by 2, right? This is equals to 100 meters squared. So we know my total area would be 250 plus 800 plus 100, which is A1, A2, and A3, right? This would be equal to, when you add them all up, you're going to get 1,150 meters squared. 50, not 5. 150 meters squared. So we now know that distance, remember distance and area under the graph is the same thing. Your distance is 1,150. So your speed would be 1,150 divided by your total time taken is 300. When we divide this, you're going to get 3.83 meters per second. Right? Distance is in meters, time is in seconds, so it is meters per second. Okay, if you want to use the formula to find the base, not the base, the quantity, right? So it would be meters per second, and that's your answer there. So now we're going to do part B. All right, so now we're going to go into part B. They said the diagram below shows a graph of 3 lines. L1, which is this line coming down here. L2, which is this line coming across here. We've seen L2. And L3, which is this line coming down here. And the shaded region R, which represents the common region for the 3 inequalities associated with line 1, line 2, and line 3, and define R. So we're going to do this table here. So now, guys, for your inequalities, right, for this, when we have the equation, it would either be y is more than or equal to 2x, or y is less than or equal to 2x. Right? These are the two possibilities for the inequalities for line 1. What you want to look at is where is shaded, right? Or where they're talking about. We're talking about this region right here. So if we were to pick a coordinate that is in this region, That is, let's pick this one right here. I'll use red so you guys can see. This coordinate right here. This is X is 3. Nah, that one is Y is 3. Hold on. Let me choose the next one. I'll use this one here. X is 3, Y is 2. We see that is in the area that is shaded. So that is in the inequality that is associated with the line. So what we are going to do is see if that point satisfies which inequality here. So we know that the point is 3, 2, and if we look at this one, y is equal to 2x. Y is 2, so 2 is more than or equal to 2 by 3. We're using the coordinator, which was 3, 2. We put in it in this equation. Is 2 more than or equal to 6? No. So this inequality would not be for the region that they are showing. So we know that the inequality that we will be using is the next one, which was y is less than or equal to 2x. Right? So you just choose a coordinate and see if which one satisfies which inequality. Now the same thing here. L2, y is equal to 2. So there are two possibilities for the inequality for that, right? We're talking about this. We can either have y is more than 2 or y is less than 2. Now, if we use the same point, we're going to use the same point in, let's use this point above here, which was 3, 3, so we're going to say that y is 3. We know y is 3. Is 3 more than 2 or is 3 less than 2? 3 is more than 2. So we're going to use the coordinates. That is this. This is 3. Hold on. 3, 3. And you're going to put it in this equation where we know our y is 3. Right? So 3 is more than 2 or less than 2. We know that y. Okay, so as we were saying, when y was 3, which inequality does it satisfy? Is 3 more than 2 or is 3 less than 2? 3 is more than 2, so we will not be using this inequality. Y is less than 2. So the inequality that we will be using is y is more than or equal to 2. Right? Then the last one here, they ask for your equation of your line. Now, we can, actually no, let's not do that. So to find your equation of the line, you have to find your gradient, which is y2 minus y1 all over x2 minus x1. So we need two coordinates from line 3. We have this coordinate right here, which is 10, 0. That means x is 10, y is 0. And this one is 0, 5. Right? So you're going to use these two coordinates to find your gradient. Right? So we have 10, 0, and 0, 5. So y2, we'll call this one x1, y1, and this one x2, y2. So y2 is 5, so it's 5 minus 0 all over 0 minus 10, which is minus a half. So we know our gradient is minus a half, right? Another way to find C, guys, C is also known as your y-intercept. So C is equal to your y-intercept. That is the point at which your line crosses your y-axis. So the point at which it crosses your y-axis is 5. So that means C is equals to 5, right? So C would be equal to 5, or you can put it, I'll do it the next way. So your equation is going to be y is equals to minus a half x plus 5. Right? This is one way. This is a different way than what we normally do. We usually just put it in the equation. we use a coordinate, let's say 10, 0, and then your gradient is equals to minus a half, and we put it in the equation y is equals to mx plus c. So that is 0 is equals to minus a half by 10 plus c, so that's minus 5 plus c is equals to 0. We want to make 0 the subject carry across minus 5, so c is going to be positive 5. So because we know c is positive 5, that is how we get y is equals to minus a half x plus c. And that would be how you would do this question right here.